Good afternoon, everyone. Welcome to Brainboss Learning Consult YouTube channel. I'm your regular host, Mr. Maru. Today, we'll be treating a very wonderful and interesting topic called binary system. Before we continue, I want to take a short break. We'll be right back. Welcome back. Like I said, before we took the break, I said today we'll be going into binary system and its operations. Quickly, let's go into the topic proper. When we talk about binary, what do we mean? Binary means operations carried out in base 2. And when we talk about base 2, it comprises of just two numbers, zeros and 1. Zeros and 1. This is what binary is concerned about. And in the computer world, they are used for programming, and they are machine languages. They can be used for programming. In electrical, it can be used for switching, where 0 is off, 1 is on. So that's why some of your switches, most times you see 0 as off and 1 as on. So these are the operations. Quickly, these are the usage rather. Quickly, we'll be looking at how they are used in terms of calculations in mathematics. So I'll be taking you through this journey of how it can be converted to base 10. So basically, what are base 2 number-based system? Now, base 2 number-based system are actually number-based system groups in twos. Binary systems are actually systems that are grouped in base 2. And I'm going to be showing you what that means. So this is 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, and so on. Now, 2 raised to the power 1 will give you 1, this will give you 2, this will give you 4, this will give you 8. You can see that it have a multiplicating factor of 2. This 1 times 2 will give you 2, 2 times 2 will give you 4, 4 times 2 will give you 8. So the next will be 16. That's 8 times 2 will give you 16. So they are grouped in 2. Likewise, base 3. Base 3 are actually number-based system in base 3. They are actually number-based system that are grouped in 3. It's just very simple, that are grouped in 3. For instance, this is 3. So this is 1. This is 3. This will be 9. And this will be 27. You agree with me that 1 times 3 will give you 3. 3 times 3 will give you 9. 9 times 3 will give you 27. What does this mean? It means that base 3 numbers are numbers actually grouped in 3. So base 2, which we'll be focusing on, are actually numbers grouped in 2. And I told you that they comprise of 0 and 1. So we'll be looking at some examples of how it can be converted to base 10 and the likes. So now we want to see how this can be converted from base 2 to base 10. Basically, in number-based system, when converting from base 2 or when converting from any other base to base 10, all you just need to do is you expand. Once you expand, you've actually converted to base 10. So expansion in number-based system actually converts that number to base 10. So quickly, I want to see how we can convert some binary system operations to base 10. So let's see this example. Let's say we want to convert the following to base 10. So let's see, let's say 0, 0, 1, 0, 1, 1, 0. All this we want to convert them to base 10. So let's see how possible that will be. So that's solution. So that's base 2. Now, this is very easy. So if there are 4 digits, the highest power there will be 3. If there are 5 digits, the highest power there will be 4. If there are 6 digits, the highest power there will be 5. Reason be that number-based system actually starts from 0. For instance, in number-based system, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. You agree with me that every number here, if I write 10, I'll be repeating 0 and 1. If I write 12, I'll be repeating 1 and 2. So number-based system generally starts from 0, end at 9. So that is why by the time I start from 0 now, you will see that the highest power here will be 3. So if there are 5 digits, when I start from 0, the highest power there will be 4. For the sake of explanation, I will just add that to the top. That's 0, 1, 2, 3. For those of you that are used to this writing up of these numbers at the top, you just start 0 from your right to the left. That's just the basic. Now, that will be 1 times 2 raised to the power of 3 plus 0 times 2 raised to the power of 2 plus 0 times 2 raised to the power of 1 plus 1 times 2 raised to the power of 0. So what that will give us basically is 1 times, that's 8, plus 0 times 4, plus 0 times 2, plus 0, plus 1 times 1. So what are we going to have? That's 8 plus 0 plus 0 plus 1. So that will be giving us 9 in base 10. Therefore, you can say 0 is equals to, this is in base 2. So 1001 in base 2 is equals to 9 in base 10. We want to take a short break. We'll be right back as we go straight to example 2. Stay tuned. So you are welcome back. Right now, we want to go straight to the example 2. So that's by expanding this, like I told you, when you have 4 numbers, 4 digits, the highest power there will be 3. Now we are having 3 digits, the highest power there will be 2. So quickly, so from our subsequent examples, I won't be writing these values at the top. You now know how they are. Now that will be base 2, of course. So that will be 1 times 2 raised to the power of 2 plus 1 times 2 raised to the power of 1 plus 0 times 2 raised to the power of 0. Quickly, that will be 1 times 2 raised to the power of 2, that's 4, plus 1 times 2 raised to the power of 1 is 2, plus 0 times 2 raised to the power of 0 is 1. So that will give us 4 plus 2 plus 0. So that will be 6 base 10. Therefore, 110 in base 2 is equals to 6 in base 10. If you follow this and practice subsequent questions in your textbook or in your school notebook or for whatever source, you'll find out that this is very easy. Expanding base 2 or binary and every other number-based system are very, very easy. So quickly, we'll be going on a short break. When we return, we'll be talking about various operations in binary system. Various operations. Here we'll talk about how you can actually change from other digits to binary, and also we'll be talking about the operations such as addition, subtraction, multiplication, and division of binary system. Just do it to subscribe, like, and share our YouTube content so that you can be getting regular notifications when we drop posts like this, educative posts like this. We'll be right back. You're welcome back. Like I promised before the short break, that when we return, I'll be taking you through how you can convert numbers, every other numbers, whatever how it look like, from that number, other number based system, to binary or base 2. Follow me as we do that shortly. So converting to base 2. So let's just take let's see examples of maybe converting like 31 to base 2. So 31 like this is just a natural number. So all natural numbers are in base 10. All natural numbers are in base 10. So I can even add base 10, or I can leave it. So just to tell you that all natural numbers are in base 10. So let's say maybe 43. So quickly, let's do the first. 31. Now, when converting from base 2, when converting other number based system to base 2, all you just need to do is to divide. Especially if you are converting from base 10, please get this right so that you don't be confused. If you are converting from base 10 to base 2, all you need to do is just to divide by 2. When you divide by 2, your answers will be in base 2. Whatever values they are, once it is in base 10, all you need to do is to divide to get base 2. Now, there's a caveat here. Now, every other base, number base that is not base 10, to convert them to base 2, all you need to do is to first convert to base 10, then to base 2. I will do, if time permits us, or in our subsequent videos. In our subsequent videos, I promise you, I'm going to give you an example. Here we can convert from maybe, let's say, base 8 to base 2, or base 5 to base 2. Now, you can't just convert from base 5 to base 2. All you need to do first is to convert from base 5 to base 10, which is a natural number. From base 10, you cannot convert to base 2. But I want to assume that these are base 10, which are natural numbers. So I want to show you how we can quickly convert base 10 to base 2. In our subsequent videos, I will make a time to put you through converting any other base other than base 10 to base 2. So for the sake of this video, this is base 10. We are converting into base 2. This is your reminder, your remainder. So this is 2. 2 into 31, and that will give you 15. Remainder 1. 2 into 15, that will give you 7. Remainder 1. 2 into 7, that will give you 3. Remainder 1. 2 into 3, that will give you 1. Remainder 1. So, of course, you cannot count 1 and divide 2 from it. It's not possible. So what you just do is that will be 0 remainder 1. You can see that. So we are safe to say that 31 in base 10 is equals to. So it goes like this. Your counting goes from bottom to top. from bottom to top, and that's why I drew this arrow like this. So that's 1 1 1 1 1 base 2. So you can see that 31 in base 10, that's what it gives you in base 2. Quickly, let's go into example 2. So like I promised you, I'll be taking you through the example 2. Example 2, that is 43 base 10. That's 43. Your remainder, that's 2. 2 into 43, that will be 20. And that 3. 2 into 43, that will be 21. And that 1. 2 into 21, that's 10. And that 1. 2 into 10, that's 5. And 0. 2 into 5, 2 and 1. 2 to 2, 1 and 1. 2 into 1, that's 0 and 1. We'll be having, like I told you, it's from bottom to top. That will be 1 1 1 0 1 1 base 2. So 43 in base 10 is equivalent to 1 1 1 0 1 1 base 2. I believe this will help you. Would have been able to help you in calculating or converting from base 10 to base 2. I'll be going into another break. So when we come back, we'll be talking about various operations involving binary system. We'll be right back. I know you enjoyed this video, and I'm promising you that in subsequent video we're going to be treating all these operations. In fact, our next topic on this will be operations involving binary. I believe you've been blessed. You just need to support our hard work by telling people about our YouTube channel, sharing it to family and friends, liking our videos, go to our Facebook page. Our Facebook page is BrainBoss Learning Consult. Our email address is brainbosslearningconsult@gmail.com. You also have our Instagram handle, is BrainBoss Learning Consult. When you check the description below, you see our various social media platforms. You can as well drop your comments. I'll follow through, and if I need to do a makeup video for you, I will. Don't forget that BrainBoss is a platform for you to grow mathematically, and as much as STEM is concerned, BrainBoss is here for you. At BrainBoss, everyone is a genius. I'm your regular host, Mr. Maro. Till I see you next time, remain blessed.